Welcome to Indian Academy for All. Please subscribe to my channel for latest updates. After subscription, you will get bell button. Please press that bell button. You will get all notification. Thank you.
A warm welcome to you all. In this session, we are going to learn about offsets. Before knowing about offsets, one of my students asked one doubt, Sir, how I will get the hypotenuse allowance? So I will clear it again. Look here. See, first you have to know what is the hypotenuse allowance. See, for example, AB distance, horizontal distance is there. From the figure, AB horizontal distance is there. See, this AB value is not equal to AC. Why? Because this is the sloping ground, this is the horizontal ground. Clear? Clear? I think everyone clear it. Right. So here, if I will take offset with the help of compass, what will happen? I will get up to the B1 only. Up to the B1 only. Right? Clear? Here I will get up to the B1 only. Clear? So here AB value, this value is equal to this value, maybe. Right? So for example, if I will take this value is 20 meters, for example, if I will take with calculated with 20 meters chain, what about this one? 20 meters. Got it? Everyone got it? Clear? Right. So here maybe angle theta. Here maybe angle theta. Right? So here B1 to C, I don't know value. So this value is known as hypotensial allowance. So how we are getting that allowance value is, look here, I will write the steps for that. Right. Look here. See, this value is theta. Clear? Right. See, first I am writing about A to C. What is the A to C? For example, 20. Right? 20 plus A. 20 plus A. Right? If I will take horizontal component for that, then what will happen? 20 plus A into cos theta. Yes or no? Yes. Right. So here, what about this value? This value is horizontal distance. Horizontal distance. Right. So here, this value definitely equal to this. Means this value definitely equal to this. Right. Clear? Right. So this will also become 20. Clear? I will write this step again. So here 20 is equal 20 plus A cos theta. I think up to now clear everyone. Right. So here bring cos theta this side. What will happen? What will happen? That will become sec. Right? 20 plus A. Then tell me the A value. 20 sec theta minus 20. Agree? So take 20 common. So then what is the A value here? What is the A value here? Take 20 common. Then what will become, what is the A value? Right? What is the A value? Right? Tell me the A value. So here 20 sec theta minus 1. If we will take A, then this is known as hypotenuse allowance for 20 meter chain. Clear? Everyone clear? Simple. Here A value, hypotenuse allowance value is 20 into sec theta minus 1. So for 30 meters chain, 30 into sec theta minus 1. So for L meters chain, that will become L, right? So I will give final value for that hypotenuse allowance, that is L into sec theta minus 1. Everyone clear it? Clearly know that. So simple. That is A is equal to hypotenuse allowance is equal to L into sec theta minus 1. Next, offset. We are knowing about offset. So here, what is the meaning of offset? I told already. See, for example, A to B, I want to calculate the distance. Right? Here I have one object, for example. So here I want to know this distance also to prepare a map. Yes or no? Yes. So this horizontal measurement, a lateral measurement from the chain line is known as offset. Clear everyone? This value is known as offset. Look here. Lateral measurements to chain line for locating ground features are known as offset for this purpose. Right? So here we have a perpendicular offsets, maybe oblique offset. Means the offset with maybe with some angle, otherwise we are getting perpendicular offset. Clear? Next. If the object is to be located, say road is curved, then we have to consider more number of offset should be taken, right? Clear? For measuring offset, tapes are commonly used, right? Otherwise we are using offset rods also. Offset rods also we are using, right? Clear? So perpendicular offsets we know, right? See, this is a chain line. So if we take a lateral measurement with 90 degrees, then that is a perpendicular offset. Read these points, random points, offsets which are taken perpendicular to the chain line are termed as perpendicular offsets. These offsets are taken by holding zero end of the tape at the object and swinging the tape on the chain line. The shortest distance measured from the object to the chain line is usually the perpendicular offset. The shortest distance measured from object to the chain line is usually known as perpendicular offset. Look here. See, this is the chain line. Here, this is the perpendicular offset. This is also perpendicular offset. This is also perpendicular offset. This is also perpendicular offset. For example, if we have building like this, clear? Next, oblique offsets, opposite. So other than 90, if we will take any angle, that is the oblique offset. Oblique distance is always greater than perpendicular distance. All offsets which are not at the right angle to the chain line are known as oblique offsets. Clear? Look here. See, if I will take offset like this, then that is a oblique. Next, this is also oblique. This is also oblique, right? With some angle. Clear? Next. Look here. See, this is the road. So for road, we have to take more number of offset like this. Clear? Right? Look here. This is the perpendicular offset. Here. Next, this is the oblique offset. This is also oblique offset. This is also oblique offset, like that. Clear? Next, for setting perpendicular offsets, any number of following methods are used. So here, how we are setting the offsets? By swinging, by using crossstaffs, by using optical or prism square. See, these three are most important. Nowadays they are asking for competitive exams like all JE, UPSC, SSC, for all exams they will ask, right? Right. Perpendicular offset by swinging. See here, chain is stretched along the survey line. An assistant hold the end of the tape on object. Surveyor swings the tape on chain line and select the point on a chain where offset distance is the least. Right? Simple. We are swinging the tape. So where we are getting the least value, there we are considered that as a offset, right? And notes the chain readings as well, offset readings and the field book on a neat sketch of the object. Clear? Simple. We are taking the offset like this by swinging. Means, see, first we are taking here, then we are swinging the tape, then that will become a straight. After swinging the tape or chain, we are getting a straight line, right? Then we consider this least distance as a offset. Clear? Next, perpendicular offset like this, perpendicular to this one. Clear? By swinging, right? So here we are taking offset, right? Clear? Next, perpendicular offset by using cross staffs. See here, three different types of cross staffs are there for setting out the perpendicular offsets. They are open cross staff, next French cross staff, next adjustable cross staff. Clear? See, these all are offsets, cross staffs we are using to set the perpendicular offsets for 90 degrees, right? Clear? So one is different, that is French cross staff. So with the help of French cross staff, we can set 45 degrees and 90 degrees. Both open crossstaff and adjustable crossstaff we can set 90 degrees, right? So with the help of adjustable crossstaff we can set 90 degrees, 45 degrees, anything we can set, right? So once read the random points. Three different types of crossstaffs used for setting perpendicular offset. All the crossstaffs are having two perpendicular lines of sides, right? Here the crossstaffs are mounted and stand. First line side right along the chain line without disturbing setting right angle line. Check it. Simultaneously we have to do in the field, right? Clear? Open crossstaff set for the perpendicular offsets only, right? But French crossstaff we can set the 45 degrees also, right? Adjustable crossstaff we can set to any angle, right? Clear? Look here, this is the open crossstaff, right? Clear? Open crossstaff, right? This is the French crossstaff, octagonal shape we can observe here, right? Below inside we have prisms, right? Clear? This is the optical square and adjustable crossstaff also like this only, right? Clear? Right, perpendicular offset by using crossstaffs, right? This is the open crossstaff or wooden crossstaff also we have a slide, right? Opposite we have a crossstaff, right? Like this, crossstaffs are like this, right? We can observe in the field, in the lab also, right? Next, perpendicular offset by using optical square and prism square. Keep in that mind, see these prism square and optical square we are using to set the perpendicular offsets in the objective. Very important. These instruments are based on the optical principle of that two mirrors are at angle theta to each other. The reflex are at the 2 theta degrees. So figure shows a typical optical square. Clear? So here the mirrors may be with the 45 degrees. The mirrors may be set with the 45 degrees, right? So here 45 into 2, that will become 90, right? So here we are getting the 2 theta, means 2 into 45, then we can set to the 90 degrees. Clear? Right, look here, this is the optical square. The mirrors are at 45 degrees. Clear? Look here, this is also a optical square and prism square. This is the optical square, this is the prism square, right? Clear? This is also, right? So in this way we are setting the perpendicular offset by using the optical square and prism square, right? Right? See, previously we can observe that the distances or the values are C and D are at different lines. After setting, this will comes to the straight line, means see here this value is perpendicular to this value, means this line is perpendicular to this line. So here automatically the offset will become perpendicular. Clear? Right, in this way we are getting perpendicular offsets from the baseline, right? Clear? Before we can observe that C and D are like this, somewhere C, somewhere D, but after setting the perpendicular offsets they are come to a straight line. Clear? We are adjusting like that. Next, 3-4-5 method to set the perpendicular offsets. See here, simple. What is the 3-4-5 method? Look here, see what is this value? By using Pythagoras theorem or Pythagoras law, 5. What is this? 3. For example, this is 4. Then what is the 5 value? Tell me the 5 value here. Clear? So apply the Pythagoras. 5 square, 5 into 5, 25. That value is equal 3 square plus 4 square. 3 square means 9. 4 square means 16, right? So here 4 plus 16 plus 9, that will become 25, right? 25 is equal 25. So by using Pythagoras theorem we have to set the perpendicular offsets, that is 3-4-5 method. Clear? One distance is 3, one is 4, another one is 5. then automatically we are getting the perpendicular offsets. Look here, perpendicular offsets, right? See, this is 3, this is 4, this is 5. Clear? This is the 3 4 5 method, right? See, this is the 3, this is the 4, this is the 5. Clear? 3 4 5, right? Clear?